Hey guys, welcome back to the channel. It's been a little bit and we're finally back here filming again. Sort of had a bit of a break from the Bronco. You would have seen last videos, the front end was pretty heavily modified. We got all the 12-inch coilovers in, you would have seen. We got the Hemi in, done most of the fabrication work on the front chassis. And that's sort of where we got to. Moving forward now, there's only a little bit of progression that sort of happened with my personal builds. And we're sort of now focusing more on the other builds for people in the background. So what we're going to do moving forward is actually start to film everything and probably vlog more than actually tutorialize things. And moving forward, I sort of still keep a little bit of the tutorial side of things and that, but it'd be a bit more fast paced and sort of show you the builds progressing, design work, manufacturing, all that kind of stuff. And there's a fair amount these days with what we're doing now in terms of manufacturing, seeing billet products, design work in CAD. The list goes on with how many things we've actually started to do. And it's pretty exciting because we're punching out some pretty cool looking things. At the moment, you can see in front of me, we have a mock-up of a trailing arm assembly. This is going to be a 4130 assembly with a bulkhead in the middle. This bulkhead is going to be 4130 billet, which then ties into a skeleton structure. And then we pick up on our rod ends and everything like that, which I'll go into, and we'll go through a bit of a discussion why we've gone this design, rod ends, and just sort of some stuff to really touch base on with the builder side of things, I guess. Just sort of the assembly and why we pick certain componentry. Moving from there, that's going to go onto a Defender. So that's a ute-based platform. And we're slowly starting to tie in the trailing arms off the back of that chassis now, some design work that I can show you later on. With the Bronco, we're currently at the rear diff in final assembly, which will still be partnered onto leaf springs. And now we'll be looking down the road of like a Diva setup, pretty big wrapped leaf spring, which gives you a fair amount of travel, and they'd be sprung over on top of the diff, and also the shackles will be a factory orientated with an extended shackle setup, basically orientated at the rear of it. The shackle does sit above, it doesn't sit below like a traditional style Hilux and that. And that is on the Spider Tracks housing, which we'll talk to on that. And then we've also picked up some new guards from the States to basically pump the front fenders by about 4.5 inch, and that's from Henneman. And that gives us the up travel clearance we need to basically at full compression be able to steer lock and still actually, you know, move the vehicle under full compression on both sides during its cycling. So no point having the original ones on there. They did look nice and they presented very well. But the up travel wasn't there, and basically it would be more for looks than actually practicality. And the plan is to, you know, bang around in this Bronco and jump it and do all the good stuff. And hopefully nothing touches, and that's the reason for these guards that we've got. So I guess moving forward at the moment, we'll touch on a little bit of the stuff with the front Spider Tracks housing, talk a little bit on that. And sort of show you a couple other little jobs we've been doing in the background, which is around a pro buggy assembly. We're doing some manufacturing for a LS mini truck setup, so some more CNC work on that. And yeah, we'll go from there. I'll walk you through a couple of things of where we're up to, and this is the Spider Tracks diff assembly, which is for the Bronco. So this is a 3.5 inch housing. We've got a heat treated back strap on this. We're running some dry brake assembly, 6-pot piston wheel woods, heat treated. 5-on, 5.5 Spider Tracks 35 spline unit bearings, and that goes onto some 14-inch rotors. So this is a pretty stout setup, and definitely not your generic kind of differential you would put under something like this on a road registered kind of vehicle, I guess. This is probably pushing more to like your desert kind of Ultra 4 to a trophy truck assembly. The 9-inch third member is yet to be decided on what we use. We might sort of sit more on the cheaper side near that, you know, 5 to 7 grand on the third member instead of going all the way to your massive big one. We have the horsepower there, but the expense can potentially be put somewhere better and speed the build up a bit more instead of putting so much money into a $10,000 to $15,000 third member. So it's something we'll evaluate, but we should get away with just a normal kind of 35 spline load bolt kind of setup on a 9-inch. Now, this is basically all tacked up and sitting in a state of waiting for the purchase to go on here for the leaf springs. And that's pretty much it at the moment. So until we receive the stuff from the States to complete the Bronco, that's sort of going to sit there and keep waiting. Moving on from that, we have another NP205 down here. So this is a left-hand drop forward 31 spline input, which does have a married section, so it's not divorced. Divorce meaning that this would be external to your transmission, and you would have some kind of adapter in between that is externally. You can see it, whether that's a uni kind of setup. This is a bolted mated setup, so 31 spline forward. There is a next size up to that, which is a 32 spline, but I didn't have availability to that, so this we can make work. Where we're sitting with this is basically trying to marry this to the 8 HP on the back of the Bronco. At the moment, it's 2-wheel drive, so looking at going to a Jeep 8 HP gearbox, which has a flange assembly on the back of it to design a billet piece to tie this in. And then we'll just float basically a 23 spline to a 31 spline coupler from Advanced Adapters. Pretty stubby, they only take up about 3 inches. Then I'll mill up an adapter between that to sort of pick up a bearing to float that concentrically so that it doesn't actually wobble around or get any kind of weird harmonics and stuff like that. Sort of that's where we're at the moment with that. And then moving on to a couple of things that we have been doing in the background. So on the Pro Buggy, we've got a nice exhaust system here. This is a 3-inch system off the back of the headers, and this rolls down to the back cage. Picks up with a nice mount on there. Fair amount we've been doing on it actually. Trans mount cooler. This is a pretty nifty one that was all scanned up and designed. You can see all the bracket assembly, the venting and all that stuff to help with the baffle from it. So that's pretty neat. We got a tire carrier which goes on the top section of it. So I had a new intake on the LS3 which rose this up a bit, so about 200 mil. We've put a 45 on the back side of this, strengthened it up, re-welded the bushes on, and then I fabricated up some coolant pipes that run down the side of this. So they are a 38 mil, which is about a probably 1.5 inches. That picks up on some AN fittings, so they're 37-degree AN fittings, which that all ties in. And then with the manufacturing stuff that we've been doing, whole bunch of different little things, but a pretty cool one is these merge collectors that probably didn't show on YouTube last time, but this is a 3/16 stainless steel machined merge collector with 2-inch primaries, and so you can see how that is pressed in there. There's no welding hole in that at the moment, so pretty nice fit. And you can see I've put a nice taper which merges them all in, so that's not just a flat section. It helps with the TIG getting in there too, so that you can actually roll up on an angle instead of trying to weld flat. The press fitting that I've done on this is to also help with not needing to weld the whole thing out. And inside it does have a bit of a neck down in there to bottom out the headers so that they all equally press to the same point. And that will help alleviate any kind of, I guess, exhaust gases coming out. Yeah, pretty nice system. So moving on to the Bronco, this is talking about the guards. The fenders on the front of the Bronco sit about a 4.5-inch bulge. And basically what that means is on the side of the fenders here, we taper off, and you can see that the top section does have a quite flat pump out. And this helps with getting that right out to the side there so we can get the up travel on our tires here under full compression, as you can see. In there's all our suspension package with our internal bypass coilovers. They're running 28 inches of coil length on a 12-inch coilover. So it's got a 20-inch long coil with a tender coil that goes on there, which is 8 inches on the top there. So basically just working that primary coil on there, and boy is it looking fat now. These are only semi-mocked up, so I've drilled some holes to sort of get them on there and that, but you do have to do a lot of structure yourself. So we will be doing a lot of internal aluminium skeleton in there to brace them all up. And then we'll bring that from the firewall back to the actual grill to strengthen that all up, so we're not putting stress on the guards. The guards are just sitting nice onto the strength of the tie-ins between the front to back, because they can handle a little bit of movement and flexion and stuff, but we don't really want to stress them too much and start developing cracks. But anyway, that's sort of where we're up to with everything. Bronco's been sitting for a little bit, but it's just sort of a timely thing with everything with the diff and the suspension package that we're waiting for. So there's a Defender that we're talking about, and this is currently in its build stage on the rear. Basically what we've gone and done is set it up to a neutral height across the chassis being zeroed out so that we can start working out our up travel on both front and rear diff. At the moment, we've got about 5 inches of up travel front and back. Any more and we start to get this car up a bit too high in the air, and we don't really want that. So where we're sitting with this is I completely stripped down the chassis, took it all back, repaired holes and stuff that were in there in pitting. We've bent it a little bit back because it was distorted a little bit. And then we designed up some 4mm braces in here. And you can see with the bracing and everything like that, we have provisions to stitch it into the actual chassis itself. And then we also do have radiuses on the back edge of this to help alleviate that stress. Obviously, if we go too sharp to a point or to a flat edge, we can start to cause crackages or cracks basically in the chassis. And then we've taken that all the way up to the middle section of the chassis here. So we have a pretty good base. We don't want to strengthen it up too much, and that's why the internal braces here don't go full length. So we've still got a nice little bit of movement on some 37-inch treps, and they're on the dirty lifes. The diff selection that we've got here is an 80 series full float. So basically it's a 9.5-inch diff, full float setup, which I've taken all the bracketry off, completely scanned this out, which will then tie into our trailing arms. So this car doesn't weigh a great deal, and a lot of people would probably question why you would use an 80 series rear. Now we can definitely run RCVs if there's any kind of axle issue with that, but being the full float design and the way it's all packaged, the disc brakes on there and stuff like that, and the actual 9.5-inch rear. If the rear diff is set up correctly, these can be a pretty stout diff for what they are. And this car itself does not weigh a great deal with the small little engine in it. So that's the reason for that, but it also gives us our offset for the drivetrain with the tail shaft. So we don't want to set it too far off angle from where it projects off the actual back of the transfer case. So you can do it, and the unis can take it to a degree on like a 1350 uni. But the more we can keep that sort of all in situ with each other, the better it's going to be. So on the backside of these, I believe they might run like an LT230 transfer case, and that is right-hand bias to where that does actually come out. So the trailing arms for this will project up to here. They run about 48 to 50 inches long, and the motion ratio, we're sitting in the middle of that arm. So we are running a 12-inch King's coilover, 2.5 on the rear, 2.0s on the front. And basically with that motion ratio, we are going to see a fair amount of articulation in the rear of this. The issue we do have with this is that the chassis being so narrow, the trailing arms will have about a 5-degree angle in it, but due to having a narrow chassis, we can't get a massive amount of pinning on the actual angle of the rear forelink. So with the rear forelink, you generally will have like that combined 30-40 degrees of actual pinning on the triangle, and either side of that either being 15 to 20 degrees on your bracket angled out from your chassis. We will see how that all sits with our upper links, and obviously the more we bring those upper links back, the more we will get more of an angle on there to control that. But then we do bring in other issues with what our pinion's doing, roll steer and stuff like that. So basically where I'm at with this is we'll probably see maybe 16 inches of travel in the rear or something like that and have it capped at that. And the reason being for that is once we sort of get over that, we can't mitigate the roll steer because we are so far one side of that actual axis of where it's moving. So if you've got 5 inches up here and we've got X amount down here, that's a lot more instead of being averaged out between, you know, 10 to 10 either side. So that's sort of one thing you got to think about when you're designing this, and when you put a folding calculator, you will see the roll steer start to come into it. It's just something we can try and mitigate as much as we can, but it's probably going to be in this regardless unless you start to manipulate the chassis and stuff like that. Another good thing with the trailing arms and the backside of this was the fact that we want to have a tray that's still low. And you will notice that most people will have 14, 16-inch coilovers on the back here. And the issue you do have with that is they sit quite high. Now, because we're running a motion ratio, we don't have to have such a long shock because we have that leverage over that distance of the trailing arm versus actually having it mounted right at the back of the diff. So instead of having 16-inch coilover down the back, we can have 12-inch coil up here and still get 16 inches of travel in the setup. It doesn't work with everything with these trailing arms, and the only reason why it's working well with this is because there's a narrow chassis on a Defender. It's not really something you would permit on a, say, Classic Patrol or an 80 series, and the reason being for that is the wheel track doesn't exceed big enough for the actual chassis itself. And stemming back to that with competitions and stuff like that with people that use those cars, what they'll generally do is actually notch their chassis in to get that. So definitely a lot of ways you can go about it, and that is sort of where we're at with the back Defender at the moment, and those arms will be getting tacked up as we start to move into assembling them and getting them on the mounts on here so we can start locking this diff in. Now, the other side over here, we've got a 45 series on an 80 series, pretty typical setup, and this is pretty much going to get a dual compound 6BT, 14 bolt in the rear with 4-link, and the front will be a Dana 60, which we will have to flip. It is a left-hand drop. We'll flip it to a right-hand side. So basically we'll have to take all the rosette welds, detube it, pull it all apart, retube it, and then probably put on upgraded knuckles like Reed or Crane or something like that. So that's sort of where we're at. And then this will sort of come into play once we get further through the series. At the moment, we're locking in heights to sort of match that 80 series chassis at a factory height, and then we can go off the chassis to ground distance as we start to build, because obviously the guards do not match a guard to center hub measurement. And most of this information comes from Vehicle Descriptor, which will tell you all of the specifications of your vehicle, and that will pretty much permit you on the maximum you can do within your state. So, bit of food for thought there. And yeah, that's sort of where we're at. We've got a whole bunch of other things and builds and stuff like that which are happening, and we're just sort of going to vlog it as it comes along and show you all those kind of things. Now, moving back onto the arms that we've got here. So a big thing is probably going to be the rod end selections and stuff like that. Up the chassis end, we have an anti-wobble setup, which is a Uniball 2.5 inch, and that is being one of these puppies here. It is a heat-treated Uniball, and the misalignments that sit in here would generally be outside of the cup. With this setup, it's 2.5 inches wide, and the anti-wobble stop is basically these misalignments hitting the inside of this, and that stops that arm from rotating too much. Now, you're probably asking why would we consider the rotating of the arm so much, and the reason being is because when your shock is in that pocket, depending if it is above or below the center line horizontally of bolt hole to bolt hole, will basically determine what swing happens in that arm. Now, if you imagine you mount that on top of that and it swings, you are loading up your shock shaft, your eyelet, and you start to damage things. Now, when you put it below, which is more of a trophy truck, you're basically putting the force applied below the center line, which stops that swing a little bit. So it's sort of like, imagine having a hammock, I guess, as an analogy, and you fill it up with coconuts, and it's sort of stopping it from swinging around so much because it's forced to stay down. You know, it's probably the best way I could sort of describe it, being below center line. Now, this doesn't sit a great deal below center line. It's probably only about 20 to 30 mil below, because we want to keep these arms sitting high enough up that we don't scrape them, because this is more of a rock crawler, not really a high speed kind of thing. So basically what I've done is got a little bit below center line to help with that force on it, and then moving forward from that, we have some protection with a anti-wobble. So that's sort of the idea behind that. On the rear, we do have basically a rod end And this is encapsulated inside. So it's a rebuildable TMR 1.25 inch rod end, and the inside of this has poly in it. So the polyurethane, which is machined up around the yoke of the actual joint, this stops the feedback through the drivetrain basically. So that vibration you get, which is metal on metal. And the best way to describe that is like engine mounts. When you have those unbreakable engine mounts in your car and you take away so much of that dampening force, you start to feel that come back through your car. Much the same as this when you start running rod end both sides. Now with these, they do have that poly race in them. Pretty cheap to rebuild. They're on the dearer side of a joint to buy, but the rebuild is quite cheap. And you're looking at probably $30 to rebuild one of these. Now this goes on the end of this, and then that will go into a 4130 pinch lock. So the pinch lock that we have here will basically give us a builder profile to put on the back side of our trailing arm here, and we'll TIG weld that in once we start to go and work out all of our skeleton structure and tie that in. These will get grafted in that. Now the best thing about these is that they're only tapped to about that far. So when you go to weld it, you're not going to have the chance of distorting this too much where your threads start to get chased out, or you elongate the inside of it like you normally would with a bung. Also too, I run 2 bolt, not 1 bolt. Depending on what you're doing, I think a 2 bolt's a good setup. The reason for this is basically once this is tapped, this here will get cut out to alleviate that so that your rod end can go in and easy, especially because you are welding it, and then the pinch will basically lock that pitch on your bolt or the rod end thread here to pick that up a bit better. So we'll start to go through and talk a bit more about the actual structure of this and pretty much start to tack it out and weld it out. Righto, so I've gone through, tacked up the jig now, and that's only the parts that are actually the brackets, not the actual assembly of the arm yet. Gone through, only tacked the outsides to basically keep everything perpendicular to the plate and made sure that the phasing of everything is pretty true at the moment. So what I mean by that is basically the pinch lock and the uni ball down the bottom there. I don't want it welded on an angle just because that will start to load up that joint sort of one way and start to eat out and change the tolerances of them and stuff like that. It's just not good to really weld them on an angle. But basically I've gone through and made sure it's 0 across the top and then in front with a square, made sure to the skeleton structure it's actually nice and perpendicular to that too. So now that we've done that, this is where we go through and we will lightly tack stuff, probably heavy tack in the middle, the outside section of that uni ball cup very lightly tack because we don't want to heat saturate one spot. It still does have the actual bearing in it. But until we get it out, we can't put the brass puck in. The brass puck basically keeps the actual shape of the cup itself concentrically even and keeps that true to itself, and also helps with heat dissipation and stuff like that. So what I've gone and done is made sure that they are both all phased and all good like that. These all spline and slot into this, which is awesome. The tops of this do need to be taken down a little bit of a flappy once we do start to assemble that up, because we want to have probably about 3 mil below the actual top of the plate so that we can get a root pass in there and a massive big cap on that. But at the moment I've gone through and basically got the width for these and minused off 6.4 mil, which is our plate, which is the center section of this, and then we've gone through and divided by 2, which gives us our average between where it floats in the middle there. So yeah, basically we are 28.8 on this one. So we sitting there, we're actually pretty good on it. I've already sort of gone and cheated here. We do want it bang on because this will, otherwise this will stuff up our little plate that we're doing on the tops of these. Now, chromoly is not the nicest thing to play with. It does crack easy when you're doing tacks and stuff, and still got to preheat it a little bit. So we're sitting 28.8 just there. Happy days. So now we go blast that with give a bit of filler on that one because I don't want to be in there too long. So at the moment I am using it's got a BBW Furic. It is a size 14 cup, and we're using a 3.2 mixed tungsten. Just tacking this up with 1.6 mil ERS 70-6 rod, and I'm using about 35 CFM of gas, just so that we don't cook it. Try and get tiny one under here if we can. It's a bit of a shit spot. The more we have on this, the bit better when we take it out of the jig. Nothing like that. A bit more oil down there. We'll have to flip that out and clean it a little bit more, some acetone. But for the most part now, we should be good to take this out of the jig and start looking at welding these completely out. Take the uni ball out of this, put the puck in it, and then we can look at basically assembling the sleeves that go around this. So I did have some ones here that were ready to mock up. Where is it? Sort of got them all sectioned and ready, but yep, like that, and then this one like that. Slow going like that. The return underneath this gets trimmed back a little bit, and then we will have a plate that will pick that up with some more runners on it. So this one here will go underneath there and cap that. The sections in this here slots will pick up that mid brace and beef that up a bit there. And then this part here will get a massive big weave that ties into the bottom of this pinch lock. On the bottom of that, then we have some 4mm chromoly, and this will be a skid plate that goes through here. I've got Xing on here that we can brace that in as a pad weld. And then we still got a drain hole there just to let any kind of debris and water that pockets or sits in the pocket. And then we got our little cool emblems here. These are 4132. It's been machined out, so once we do go through and completely cap this, this will then go on here and tie all this arm in. So yeah, the front sections of these a little bit more complex just because we have the bushing, and we sort of do need to, oh, it's going to go this way, come in here and start to graft it in a little bit, just because when you do sheet metal in CAD, you can account for this a little bit, but as you do the bends, obviously, because we are doing a scallop in this, which is basically taking out the circumference of that uni ball, one side's going to grow because you're going to start to roll this around and it's going to taper off, which generally will mean the inside edge of this, depending how you design it, will most likely be too proud, and you'll have to scallop it out a little bit for it to slip on. But there's no real issue with it because the more material we have here that we can scallop ourselves, the tighter we can get that fitment. Not everything always works in CAD once you start to do tapered splines on thing, and especially this material being 6.4 chromoly, this is not an easy thing to bend, and it's got a shit ton of spring back in and stuff like that. So we've actually come out really good, and like just for me to hold them up against there and they sit on there pretty good, pretty impressed with that. So I can't complain there. Anyway, we'll knock this out of the jig and get it on the table, get the other one tacked up, and then we can start doing all the assembly. We've got the arms all tacked up now, and cleaned up. So at the moment, they're just sort of heavily tacked across all of the faces and everything where all the sheet metal joins, enough to sort of to cycle the suspension once we get it under there, and we'll fully weld them out later on. Once we sort of commit to welding these, we'll have to maintain that constant temperature throughout it so that we don't have any contraction issues or cooling temperature differences by basically pre or post heat on the chromo. So we'll commit to that once we are finally happy with all of it. Got the nice little billet connections in here, you can see. These will go onto the diff. They're like a 10mm thick 1020. And just to finish off on the top section of here, once we've gone through and done our cap weld on this, we'll tie it off with a nice little billet emblem we've got here. Just at the moment, they're been pretty much cleaned up with a 240 grit, a bit of a polishing disc, just to sort of take that, you know, forging kind of mill scale on it away. And then basically I've gone through and FOSSed it. So I mentioned before, the FOSS seal that I use is a rust inhibitor. It basically just goes on with a squirty bottle. Now, pretty much every squirty bottle I've used doesn't really last too long, so I just use cheap ones. They're like $3 from when I've been after a project. They all clog up and seize up this, so you could use a gun, but I'd just be cleaning it then. So that's the stuff there. Pretty good for how far it goes, especially on the raw steel. Everything I do is generally raw steel, so it all welds nice, and that sort of keeps it all nice and fresh. Shock package that we're using is the 2.5-inch Kings. So these are the ones that we've got fresh, which are 12-inch. We'll change out the rod ends on this to give maybe a 2-inch extension. Basically, that just sort of helps inside the pocket of this with the roll. King do have this kind of bottom section seat where your coil goes onto, and it's quite low. There is enough movement in there, and it probably won't touch, but if we don't permit this now and we make coil over towers, and we don't have that provision there, we'll take a bit of up travel out of it once we do make this. We could work back from that. Obviously, we do have a lot of movement in this, so we could probably afford to lose a little bit of travel too. So we'll just work all that out in CAD and see how that sort of permits on here. Moving on, a couple other stuff that we've got back in the shed is the mini truck here. So this is one I did a cantilever rear suspension on it. It's still currently in a project stage. As you can see, it's been rubbed down and all the other jazz parts of that. But basically, this has come back in. We're going to fix up some little bits and pieces here because it sort of got rushed out for an event mid last year. And then we've obviously taken on a hell of a lot of work on the front end of it too. But just to sort of give you a bit of perspective, I'll take some air out of the bags. And you can see how much that bag's out on it. So we still do have some things we need to adjust on it. So basically on these bags, just because we do have so much movement up and down, we will be putting a billet spacer underneath that to try and get the bag in a better state instead of fully extended out, which will help with that. These bags aren't really technically being used in their correct state. They normally bellow on the side wall of and sort of push against themselves. So yeah, obviously cantilever system. And that was done off with a Subaru unit bearing just because they were a 95mm PCD, which is the smallest unit bearing assembly I could get to make up these arms, just so they weren't so big. And we did all the billet caps and pretty much everything all in this, fabricated the air tank, built the 9-inch completely from scratch. That was a sheet metal housing we made. Yeah, got a carbon fiber 4-inch tail shaft there too. So fairly extensive rear end. And then moving on to the front, it's got a pretty big 7-litre engine in it with a blower. And I'll quickly lift this up so you can see. We've gone through and made all billet arms in here. Different orientation too on the normal rod end there. So you normally have those bolts going horizontal with the chassis. Opted for a bulkhead that goes onto the chassis there that's tapped in with a 12-point grade titanium bolt. We started to build off onto some LS headers here, billet flanges. We've got some billet engine mounts in here too, which are pretty nifty. And then also too, the hubs are fully custom made out of chromo. So they're sheet metal housings that we've made all up on there. And then we retrofitted a Kun 26 steering servo rack to this too, which we're starting to build off for the intermediate shaft here to connect up. And then you can see the chassis too was all custom grafted and actually made to suit and graft into the original back section of this chassis here. So a bit of work on that too. At the moment too, we're just about to kick off some scanning. So this is a Revo Track It. Basically, this will let you scan without any kind of, well, I wouldn't say markers, but a lot of markers. So it only really needs to see 5 reference points over like a 4-meter field of view. So we'll be able to scan this whole front end. Basically, there's a couple of little dots on there, and it uses a bulkhead assembly here, which houses the scanner. And basically, this is the tracking section. So it tracks the scanner instead of tracking the dots. So pretty much all you have to do is have 5 reference points on here for the scanner to know where it's positioned, and then you become the tracking device. So as you move around, you just have to have that assembly in field of view, and you can scan this whole car pretty easy. You can do another thing where you set up global markers, where you will pretty much put a couple of markers around it, scan the car with this quickly, and then it always has a reference of where this car is in space, and you can pretty much just go through and scan that out. So we'll go through, scan out this bull bar, and then we'll probably jump back into CAD and go through the Defender and start showing all the bracketry that we're going to get laser cut out and start designing this rear foreling. Well, we're back on the computer and we're currently in Fusion looking at the Defender's rear end. So a couple of months ago, we went through and did a rescan on this, made sure the chassis was actually all usable and okay to use, which it did have a little bit of torsion twist in the back of it, but being a thin chassis with a long, skinny, narrow section, it's probably pretty common in one of these, to be honest with you. So we're not super worried there, because at this point through this center line, we don't have any issue, and it's fundamentally where we're all building off. So it is always good to check things before you just go ahead and start building, and that's basically what we did. So let's go through a couple of things and talk to it. So we got the 80 series rear diff in here, fully de-skinned, and that is a scan off the diff in the shed that we're using on this vehicle. Now, the rear pinion output from the transfer case is going to be pretty well in straight right-hand drop. Being in like a LT230 or a Defender rear transfer case, that is the orientation of the back side of that. Patrols come centerpiece, and look, you can use a patrol rear in this. A patrol is a 9.25-inch crown. This is a 9.5 in a cruiser, so when it comes down to that kind of stuff, I think people get a little bit misled on how strong the differences are and everything like that. They all both have hemispherical deflections and everything like that in there. It's much as muchness. A big limiting factor to these is generally the nuts inside this flange here on the full float actually having breakages where they'll snap off and spin that. Or, you know, people just not building diffs properly, basically, driving around with a shit ton of backlash, or putting lockers in and not setting them up properly and having that. Now, we will have the stage to basically go to an RCV rear axle and have this diff built pretty nice with an air locker. And I think we'll be happy days in a car that is basically 2 ton with a very tiny engine in it. So this is going to be a bit of a low speed rock crawler. So what we're going to do is talk to a couple of things. Now, basically, you can see our mesh that we do have here. That is all sectioned, and that is the reason why it's color coded, because it is all different selectable bodies that we can derate, and we can take all that away. And that makes efficiency when it comes to CAD, especially if you're working on something that is very large in its actual sizing of data. Because every time you move this around, you have to move all that stuff in space, and this has to encode that and basically, you know, translate that to its new position that you've just pushed it to. So it's a lot to move. And the more you can derate stuff and make it more efficient, it is easier in CAD. That is also dependable on your computer too that you are using. Luckily enough, I'm working on a pretty good stout PC, so I can generally get around most of those issues, but I still like to do it as a good practice. Now, we've gone through and done some 4mm rails down the side here to strengthen it up. The internal ones aren't super long. They don't go past this point because we don't want to make this whole rear section super rigid. But we want to tie this into the point of where we will have our pivotal motions on our actual lower arms here. And you can see our bracketry that we started to design. Now, we'll jump to the other side, and this is version 1. Version 1 was a lower frame plate, and it basically did not exceed past this point, so that dictated the mount that we started to create.
I was like, okay, we'll try and make something. Probably could have made this plate a little bit longer and took some more stuff off the chassis, like the body mounts and stuff like that, because they do tie in elsewhere. So I played around with the design here, and I just didn't like it. It was functional in itself and that kind of thing, but it just sort of looked like it just finished wrong in my eyes. So I decided to basically change to a longer chassis plate, and then now we've tied in our arm here, which will locate. So on the top section of this, we will put some slots in here, and they'll tie into that frame. So both these are on the same side, each side. And what we'll do is basically build this mount onto the plate before we put it onto the car. Pretty much tack this to the table, weld this mount out, and do a really nice weld. A lot of these kind of welds, because you are welding on angles and that, a lot of people don't weld them out very good because the weld is obviously falling or underhand and stuff like that. It's not a problem welding this by all means, but why not make it nicer than what we need to? And especially this point here. So many people put a cold weld up here because basically they're just letting the gun do the job and they can't see it. So what we make sure is that we've got a bit of integrity with what we're doing here and pre-do all this so it's all nice when we put it on. As for the actual chassis stitching, we do have a nice little design here. It is radius, so we don't have straight onto the chassis, and most people would generally do like a circle or something like that. I prefer to do this because as we weld this out, we do have a nice cap which holds this in, so it sort of looks blended in, opposed to having a big circle across his chassis and you got these big janky welds everywhere. That is our nice billet arm here, and this has currently been designed to suit a offset smaller than what the customer might use. So this is currently sitting at 0 offset, and we have 15 mil of play in this section here. I've pushed it to sort of the most we can, and the reason being is I want this angle to project here more than 5 degrees because traditionally you want around 30 to 40 degrees of pinning angle in the middle of this fall link here. And that depends on if you're going double triangulation or parallel lowers. Now, because we are using a narrow chassis here, which does permit the trailing arms, we do suffer when it comes to the upper arms in here. So we can make the upper arms shorter, which does give us more angle, but then we do have other issues with how everything operates within that fall link, rear steer, pinion roll, all the other kind of stuff. So what I am basically coming to the point where we will build this top section of our truss layout. And what we're going to do is we are going to orientate the uppers in a flat orientation instead of a horizontal orientation on the rod end. So what that basically does is instead of having a rod end here and here with an orientation vertically so the bolt goes horizontally, what that does do is you have to have the separation in the middle to let that bolt and everything like that, clear and everything like that. What I'm going to do is going to bring them together a little bit. And what we will achieve there is just a bit more angle. We'll probably see maybe an extra 5 degrees across that pinning of that. And I think that'll just be a little bit better. And obviously where we are situating this, that joint has like 40 degrees of flex in it. So 40 degrees over 1200 mil long lowers, it's a lot. And being the 12-inch coilovers that we do have in this, we will not be using the full 12-inch coilover, I dare say, in this, because the issue we have is we are keeping this quite low, which is what we want. We don't want a massive big car. We also want to keep it so that it doesn't exceed the vehicle descriptors guard to center of the front wheel or rear. So we want to be around that 3 to 4 inch, no more. And that is the reason why certain things are a certain way. And the travel, I would say we'll see about 5 inches up, and maybe about, I don't know, 12 down or probably a bit more. But we'll just see where we get it because obviously there is a point where we can't control the rear steer because one side is going to overcome itself. So you will see in a calculator, which I will go into once we do finalize positions and stuff like that. Um, Depending if you have a double triangulation, so if these lowers went under the chassis and then we had our four link uppers like this, we would reduce that roll steer greatly. And basically, when you average it and look at it, it's either going to be the positive or negative side of where that does actually push that rear steer through. So you just got to see what it does in the calculator, and at different set points of your travel of up and low, you will see where that does sit. And you know, you can only mitigate things so far. So there's no point having 22, 24 inches of rear travel going down if, you know, it gives a lot of rear steer. We're basically just getting, you know, show pony kind of stuff here. The reason why other trucks do get that with this kind of classical design is because they're not working around chassis like this. They've just got back ends cut off, or they're full tubular design race trucks and stuff like that. So the design is all well and good, and there's other benefits to reason why we did choose this is because by having a 12-inch coilover at a pivotal location here, we get to have that travel that we need and that we want out of the rear end of this. But we also get to achieve a couple other things. So we get to have, like, you know, a sway bar off the backside of this arm here, which can mean that the frequency and the actual travel of that arm is a lot less than having it off the back of the diff. So having links that are potentially 3 times longer and moving, you've got more chance of, you know, those arms getting stress on them, bending, stuff like that. We've got a nice little arm here, and it'd be very similar to like a Can-Am or an RZR or something like that, like a side-by-side. Limit straps we'll have over here off the back side of this, so we can reduce how long those limit straps are instead of having big ones down here. And I guess just packaging really, like by having the backsides of these arms, or having these arms where they are, and all the packaging that we gain from this gives us a lot of, you know, stability. One, because our location for these outers are so far out on the diff that it's basically, you know, holding the widest point of this diff to be, you know, stable. In most circumstances, you'll have a chassis which is here, and you'll have your coilovers mid-frame on an angle. And what that does cause is a narrowing point of where that movement on that diff is not spread out across its range. So you're creating something to be a bit more wobbly and probably more likely load up the shocks and stuff like that more than they need to, and potentially ruin seals and stuff like that. We do also get a benefit with this Defender chassis too by having our hydraulic bump stops on the outside, which will kick on a bit of an angle to basically pick up low speed articulation bump and parallel bumps. So most people will set up a bump stop inside the chassis here. Under articulation, it's not even going to touch most of the time. If it does touch, it means that you've taken away from your parallel setup. So food for thought there too. But basically what we're going to do now is we're going to laser cut out this new 4mm brace on the chassis, and then we're going to go through and deconstruct this down so that we can get this all sheet metal folded and everything. And within Fusion, when I design this, I do this in sheet metal design, so I can pretty much go up to the top section here, find a flat pack section we want to do, and let's just say we want to undo this brace on this, not brace, the actual internal section that we pick up on the bolt. In the roll access of this 2.5-inch wobble joint we have here, I have got some, what would you call it, spacers that will weld in here. This is a bit of segregation for the diagonal change on the measurement of this bush. We don't typically need it due to the amount of movement this bush sees at the location of the chassis, but I just always like to do the little things so that we don't have those issues. And it gives a bit of space in there too for, you know, welding out contraction, and don't have to have this face-to-face on there. It's just good little thing, and it also helps with elongation of the joints and stuff. So like obviously a plate like this is only going to be 250 to 300 MPa mild steel. This space is going to be like a, you know, 1020 or something like that. Now, the longer that we have that on here, the less chance that that bolt is going to have to actually wobble this out. And I do understand we do have this side skinned, but be honest with you, it's more just for looks in this practice because we do have these spaces inside. But even having these double skins, they still do chase out if we have issues with bolts. And determining the bolts that you have on here, I generally drill these out with a drill bit. I don't actually laser them because a laser can have a different, you know, curve and everything like that to what your bolt circumference is. So if it sits loose in there, moving back and forward, you will have that issue. So I generally go like 3-4 sizes down on the millimeter. So if it's a 3/4 inch or something like that, like a 19.5, I'll probably go like a, you know, 15 mm hole or something like that and drill them out to that correct size so there's a nice fit. And then also the shank of the bolt is another factor you want to look into, because different high tensile bolts and all that kind of stuff can change that thickness or OD over that actual bolt too. So probably getting more into a bit more race car stuff there, but It's always good to know these things and bring those practices in. I always like to try and bring quality anywhere I possibly can. I just don't think there's a reason to lack in it if you know the knowledge towards it. And I do try and implement that into a lot of things. So as I was saying, with this flat pack design here, we can go select that face. It will kick it off as a sheet metal design. And that's pretty much it there with a CNC fold in the middle there with our pulley splines. So now we can go through and basically, get that ready for DXF cutting. Get that up. You can see we've gone through there now. We've got a file that we can get that cut out and basically CNC bend that, which will then go into that for us, which is pretty cool. Well, guys, we're going to call it there. That's a pretty hefty episode so far, and we're going to start portioning this out so we can get the builds happening and get the videos rolling for you guys. Pretty well, we are going to go through now and smack this out and get it all laser done and have it fresh to ready to slap on the next episode for us. So we'll have that on there and we can start to get these arms fixtured onto the Defender and really start to form up the rear end of this car. All right, guys, I'll see you in the next episode. Thanks for watching.